Hi students, and we're going to be continuing our series on factoring special cases. Here we're going to be factoring difference of squares. To start off this example, I want you to practice this binomial product. A plus B multiplied by A minus B. So pause the video and give it a shot. So what we'll find is we get A squared minus AB plus AB minus B squared. And collecting our like terms, we get A squared minus B squared. Now, this is what we mean when we say a difference of squares, where difference simply means a subtraction operation. So anytime you have two perfect squares being subtracted, you can factor them into the form A plus B multiplied by A minus B. So I'm going to illustrate this using a few different tactics. So let's start out with a pretty easy subtraction question. 64 minus 49. So this is equal to 15. And we're going to confirm our answer by using difference of squares. So I can rewrite 64 minus 49 as 8 squared minus 7 squared. So clearly it's a difference of squares. And we're going to use our identity that A squared minus B squared is always equal to A plus B multiplied by A minus B. So here, this is equal to 8 plus 7 multiplied by 8 minus 7. And let's show that this must indeed equal 15. Well, 8 plus 7 gives us 15, and 8 minus 7 is 1. Multiplying these together give us 15. Now you may think this is just a coincidence, so let's charge it with some different numbers. So here we've got 121 minus 81. Again, a difference of two squares. So now, 121 minus 81, well, this is 40. And let's confirm using our identity. So 121 is the same as 11 squared. 81 is the same as 9 squared. So now let's apply the difference of squares formula. This is going to be 11 plus 9 multiplied by 11 subtract 9. And let's show that this must equal 40. So 11 plus 9 is 20, and 11 subtract 9 is 2. 20 times 2 is exactly 40. So we can see that not only will this work for numbers, but shortly we're going to see that this will work for algebraic expressions as well. So here I've got 36x squared minus 25y squared. In order to use difference of squares, we have to confirm that these are both perfect squares. So I can rewrite this as 6x all squared subtract 5y all squared. Now we're going to use our identity. So if this is my A value and this is my B value, I'm going to have 6x plus 5y multiplied by 6x minus 5y. Again, simply using the identity that A squared minus B squared must always equal A plus B multiplied by A minus B. So let's try one last example here. So here we've got a fairly intimidating looking question. The first thing that we want to try doing is, whenever possible, factoring out common terms. So that's your first step. Pause the video and give it a shot. So after factoring, I'm left with 8x squared y squared onto 25x squared minus 16y squared. Notice that 25x squared is a perfect square and 16y squared is a perfect square, and we're taking the difference of the two. So let's rewrite these terms as squares. So now this is my A term, this is my B term, and we're using our identity A squared minus B squared is equal to A plus B multiplied by A minus B. So what's our final solution? So applying our identity, we find that the final factored form, 8x squared y squared onto 5x plus 4y onto 5x minus 4y.